That way we can capture your content. Okay, please proceed.
Oh, so I went to the manual. I've forgotten what it's called now. And read about how to set up the serial plotter and loaded the little example app they had there,
Okay.
and it plotted just fine. So now I'm trying to, and then I changed. I have the demo for the ball switch that came with my kit.
Okay.
And so I changed that. Originally, it just flashed an LED, so I changed it to printing out the value of whether it was one or zero, and got it to plot that without any trouble. So now
Okay.
I'm trying to use the little app that reads my joystick, and so I modified it a little bit so that it put out two variables, and to the 9600 baud output, and
Hmm.
and that comes out fine when I turn on the printer, but when I turn on the plotter, it just sits there. I don't know what I do different.
Okay. Well, okay. So why don't what we're going to do, that's a great segue
Hmm.
into the layout today for the meeting. So what I want to do, I'd like to provide some education slash lecture time, and that'll probably run about probably 50 minutes. And then the remaining time we can have as individual or group discussion kind of projects and troubleshooting and Q&A and feedback stuff. And then at that time, Doug, we can maybe have you do some share screen, and we can discuss as a group maybe solutions to your problem, and all that kind of thing. So would that be cool with everyone
Yeah,
if
that's
we proceed that way today?
Yep.
Okay. So let me go ahead and share my screen. All right. Okay. So can everyone see my screen?
Yep. Yes.
All right. So I'm gonna okay. Let's see. Okay. Okay. All right. So I'm glad all of you are here. This is the April version 2025 of the Build It with Arduino Meetup Group meeting. So in general, the online recording statement, I already started recording. So this is sort of a mute point. But the idea here is that I hope that we're all cool with having our video and audio shared. Primarily, what I do with these recordings, the MP4 recordings, is that I place them out on our group YouTube channel, and also just in general for later consumption. And I have instituted a new code of conduct methodology that I'd like us all to make sure that we are adhering to, including myself. I am certainly by no means exempt from this, but the official copy is actually a document. I think I've got it uploaded as a PDF, but the official copy is on Discord off of the Pound Rules channel off of the server. And so the expectation for all of us is to be respectful of everyone. So that way we can have fun and learn at the same time and be respectful. And I ask all of us to use short and to the point questions. And by all means, please never interrupt any one of us who are speaking at any one time. This allows, again, for a safe, fun learning experience for all. So to start off our meeting today, I want to make some announcements. There will be, regrettably, no next month or May meeting. We will be instead reconvening at the end of June, specifically June 28th. And the reason for this are twofold. I have, number one, I have really no available time on a Saturday during May for hosting this event. And also in May, specifically May 31st, through the Seattle Robotics Society, we're having our spring version of our mini Robothon event. And so I'll be participating and helping as a coordinator on the day of the 31st. And to that end, I also invite all of you who are in the Kent local Washington area that if you want to, you can check out robothon.org and you can find all the event details either for registering, participating as a robot builder, or at least coming and watching all the festivities that day. I can guarantee you that there will be some Arduino based robots present that day. So that'll be a good segue into further creativity and thinking about how to apply what we're doing in Arduino learnings with robotics. Okay, that's what I wanted to say about announcements. So some general info. So we're going to be talking today. We're going to concentrate on C and C++ programming, the languages specifically. And today and in the future, I want to clarify something that I was thinking in retrospect at the inception of this group. I wanted to state something that I don't think that I ever did, in that I'm not going to be providing instruction on how to program either in C or C++ or any other language that we delve into, let's say, for instance, Python. And instead, you should be taking the initiative and doing your own studies. Now, I've been providing and I will continue to provide today some suggested resources for textbooks and information that's available out there for all of us to learn and consume from on C and C++ programming. So that's kind of a general directive that I'll be using from here on out on programming. And today, part of the lecture material I want to talk about is I want to point out features that you should get familiar with across both languages and that are different. What I mean by C and C++ languages is the standard that's out there. Standard as far as regular PC programming and server programming versus what we're delving into for Arduino programming. There are some key differences, and I want to point that out as part of the instructional content today. And as I just alluded to, there are many good free and paid C or C++ language trainings available either on YouTube, Udemy, and the like. Okay. And so my programming and Arduino focus for this group is to be your guide on how to use your programming skills to leverage Arduino projects. So that's just kind of a general info section. And so what I'm going to do is I'm going to ask everyone to take notes as I cover the material today ahead of workshop time. I plan on having plenty of workshop time today, and a workshop and open floor Q&A. Okay, so let's get going here. So a review of C and C++ languages, the standard and Arduino variant. So I have provided some. Okay, so let's talk about C right now. Okay. As far as the standard is concerned, now this is aside from Arduino. far as the standard is concerned, there's what's called the ANSI. It's an American Institute Society, is what ANSI is coming from. There's the ANSI standard version, and various over the years. I mean, C has been in. It was originally developed, I think, in the early, let's see, the late 1950s or early 1960s, and so C has been around a long, long time, and so there's been various versions in ANSI standards that have come along for C. And so the textbooks that I've been recommending and that you can find all over the place, including on Amazon, either to purchase a physical book or an ebook. They concentrate on the language syntax, the way that you program with C, and then they also talk about that content in retrospect to a standard, to the ANSI standard. So in general, I'm just going to talk about some bullet points here for important concepts for the C language. So C is considered a procedural language, okay? And so the main elements of C are what's called main. That's where program execution starts. And program structure is delineated by .c and .h file extensions. Okay. Now again, I apologize if a lot of this doesn't necessarily ring with what it is that you've been studying. I'm just kind of giving you some generalities here for as you go through on your own time and as we work through as a group on your questions about some things that you need to be aware of regarding C. Okay. A big part of C and C++ is what's called the preprocessor. And what happens in the preprocessor stage of processing your files ahead of compilation and then eventual executable that is then runnable either on a desktop or server or on Arduino is the preprocessor takes your textual content of your program and it processes, it does a bunch of substitutions and it shortens some of the content that eventually gets plugged into the final binary. So that's just kind of a generality of what the preprocessor is. Fundamental data types. That's a hot button in a distinction between standard C and Arduino. And the main thing that I want to talk about, there's a whole bunch of standard data types. Okay. There's int, there's char, there's the floating point types like double and float. Okay. So the main difference between Arduino and the rest of the world, aside from other embedded boards, is the difference between float and double. Okay, so the distinction here that I want to point out is that with Arduino, double is the same as float. In other words, float and a double both represent up to, or they both take up to 4 bytes each of memory, versus in regular land for the standard, a float will take up to 4 bytes and a double will take up to 8 bytes. So that's an important as far as what you can do for either storing, accessing, and doing computations on floating point numbers. That's an important thing to have in your, to be knowing about. Another thing is to do with constants. In other words, numbers, letters, etc. Everything in C, of course, is ultimately represented as a number. But you can, of course, have strings. You can have individual characters like A, B, C, that kind of thing, as well as either integers or floating numbers that are constants. In other words, you declare them as being a constant, and then that number or character or string doesn't change during program execution. So that's what the concept of a constant comes in. Keywords. Every language out there has keywords that are part of the syntax and the character of the language itself. And these are what's called reserved words, either keywords or reserved words. And they cannot be programmer redefined. That's the important concept there. Operators and order of evaluation. So operators like to do with subtraction, addition, modulus. Modulus is a way of performing in computer terms. It's a way of doing division where only the operand of the result is stored rather than the remainder also. So that's what a modulus is, and that's represented in programming terms by the percent key, or the percent key. So, and then order of evaluation, that's always important to note the way that if you're defining a line of code that performs some sort of functional calculation, for instance, you need to know left to right, right to left, and looking at right and left hand or not commas. Anyway, brackets. You need to look at the way that the brackets and the way that left and right hand rules operate to know how that calculation is actually being performed on the computer. So order of evaluation is always an important set of rules to understand in any programming language. Flow of control, for instance, like while loops, switch statements, the continue statement, if then else definitions, etc. Flow of control is an important operational idiom and syntax set in C and C++. Functions. Okay, so I'd mentioned before that C is a procedural language, and in addition to main, okay, both the function main and the file main.c is a key part of C language as a procedural language, but also functions are the other key part of your design and the way that data is manipulated in C. So functions, say for instance, if you're developing your own power of two function, you can define that. And there's also a set of, provided in the standard library, there's also a set of functions, like for math functions, time functions, etc., that are available. Storage classes. That is in representation of static, volatile, and constant. So storage classes, that has to do with the access level of a variable or a constant that you have defined in your program. And those are mostly seen and used across what's called multi-file programs, the way that you subdivide logically all of your files and what it is that's in all of your files. By the way, the Arduino IDE supports multiple files for any one project. And organizationally, that's something to be employing as you are learning Arduino, or as we are learning Arduino programming and putting the logic of our programs together, is to use multiple files. Memory access. Now, a key difference between Arduino and the rest of the world is that with Arduino, it's or really any embedded system, that dynamic memory is really not recommended unless you've got a system where additional, like external to the processor, additional RAM chips are added to your design. That, for me, anyway, has been the only realistic way to utilize dynamic memory. Um, Dynamic memory functions are new and delete in C++ language, and also malloc and free in C. So utilizing dynamic memory is a very key and more or less more advanced programming concept, but it's very, very powerful for doing a lot of real powerful programming. There's also arrays, pointers, and strings. Now, on Arduino, strings are different in that, so if you're looking at the Arduino library reference, I provided that link previously in previous materials that I've sent your way. But they talk about the way that strings are different is that there can be, just like in C, you can declare what's called a char data type, a char array to define a string. But you can also, in Arduino, there's a C++ object called string. And so we'll get to C++ and objects here in just a bit. But what I'm getting at is that with Arduino, there are two ways of utilizing strings. Okay. There's also in C and C++ structures and unions. So that's a way of collecting data into centralized buckets, if you will, or containers, because in C, since it is procedural, data is considered secondary, and functions are the key procedural part of the language. Whereas data-wise, again, it's considered secondary. You have to, in C, data is treated differently from functions. And so you can either have single language-defined elements or structures, say, for instance, an array or a float or a double. And then also you can define your own, in a creative way, groupings of data that can be manifested either as a structure or as a union. So again, I'm not going to get in because I'm not going to be teaching C programming, but that's something for you to, as you're looking at your C language textbooks, that's something to be watching out for, are structures and unions as far as what they are. And it's a key leverage point to be utilizing in programming. Okay. And I apologize if a lot of this is refresher to all of you, but I'm not quite sure where any of us are at in the spectrum of knowing C. That's why I'm going into a lot of this. Okay. So in C, since C has a standard operating system that it is utilizing on a PC or on a server, C supports a lot of the communication between the computer hardware itself and the operating system, or in other words, input output or I/O. Okay, and Arduino, that's mostly non-existent because Arduino and let's see, the Arduino variants of C and C++ don't have a traditional full operating system. Sure, you can have some operating system functionality on an Arduino, which is kind of considered like a real-time operating system or a kernel. You can have components like that that are running in background tasks, kind of simulating a regular operating system, but you don't have the full operating system. That's what it is I'm getting at, like you do with a PC or a server. Therefore, there's a whole bunch of traditional C functions that are not supported in Arduino variants of C and C++. Say, for instance, printf, scanf, fopen, and fclose. Fopen and fclose are for files. Okay, so that's kind of a general thing there. And then, of course, where a lot of the power of C and C++ both comes into play is what's called the standard library. Now, there are a whole bunch, if we're going into C++, there are some additional standard libraries, but the key one I'm talking about at this juncture for C is literally called the standard library. And the standard library has a bunch of ancillary extended functionality from what the core of the language itself offers. That's the whole idea of a standard library that is already fully tested, and it's out there for programmers to use and employ. So, and these are functions, combination of functions and header files that are defined either as .h files or .c files. The headers are in .h and the actual functional implementations are in C files. Say, for instance, if you look up C, the part of the C standard library, you'll see time, a set of time-based functions that are included in time.h. You'll find a bunch of what's considered on the PC side of things, standard input, output, those kind of things in what's called stdio.h. So there's a whole slew of standard library groupings and functionality that I wanted to point out. And regrettably, since Arduino is small, compact, and again, no formal operating system, a lot of the functions that come standard with C are not implemented on Arduino. And that's where a lot of the the Arduino library reference manual comes into play, and other resources that we're going to be getting into today to help you really understand and disseminate, well, what is it that's really available on the library side, on the C or C++ side for the actual implementations that are actually available on Arduino, and that are not. So with me, when I was first learning Arduino, that was something that I really struggled with. And so that's part of what it is I'm going to help guide you through as far as helping to understand that. Okay. And then lastly, on the C side, I wanted to just mention about syntax and idioms. Okay. So you'll see in any formal C and C++ textbook, you'll see a whole section in there about syntax. And what that means is the set of rules to construct a legally compilable program in the language. So that's what syntax means. So it's going to have all sorts of really strange looking colons and semicolons and brackets for optional and required elements, all that kind of thing. That's what syntax is. And so it comprises file program content, definitions, declarations, the way that you actually formally declare a variable or a structure or a union, for instance, statements, in other words, code statements, and also functions. Okay. So to help you understand in general, to help you understand Arduino C, as I'd mentioned before, it's important to be familiar with traditional or ANSI C and C++ used on PCs and servers. Besides the study of the Arduino language itself. And so, again, I provided some of that instructional material to all of you before, but I just wanted to restate that again. Okay. Okay. I know I'm more than likely I'm delivering all this kind of as a fire hose, but we will all of us have access to the recording. And so I hope that you pick up little bits of all of this kind of stuff today as live as we're going through this. But what's great about our group is that you can go in and you can re-listen and reconsume the information, and also do your own self-study to help you understand all this content more. Okay, so now let's talk a little bit about C++. The main languages for Arduino are both C and C++. Okay. So in general, C++ is a superset. In other words, an augmented set of additions to C. C++, of course, was invented and made popular after C. So C++ has been around for a long time also. And I think it was originally developed in the early 1970s. And I think, I don't remember now the exact date for C++. But anyway, you can find that kind of thing out. But in general, for C++, there are also ANSI versions. There's been a whole lineage over time of C++ improvements and version numbers that are part of the ANSI standard for that language. Okay. Now, there's a lot of differences between C and C++ because C++ is what's called an object-oriented programming language. And what's in a way kind of sad about C++, since it was originally derived from C and inherited a lot of the C syntax and things that you can do in C, is that you can claim that you're a C++ programmer, but you're really not using any of the object-oriented features. You can just program in using C syntax and idioms, and yet utilize a C++ compiler and supposedly generate a C++ compliant program, but it isn't really object oriented. So that's something to be aware of whenever you're learning C++. And then where a lot of, besides moving to a different methodology or what's called paradigm of looking at a procedural language versus object oriented, is that in addition to needing to think about programming differently, which object oriented forces you to do, with the way that C++ is structured, is that you need to understand the way that what's called objects and the way that objects relate to each other, polymorphism. There's a whole bunch of technical terms that are associated with object oriented. Is that one of the big problems is not only understanding object oriented concepts and how to program in the language, but you also then have the backbone of also needing to merge that, what you're doing in object-oriented space. You also need to merge that in with traditional C type of methodologies, because a lot of what you need to do when you're utilizing object-oriented structures is you need to implement them a lot in the C syntax and idioms. So there's a lot of back and forth sets of skills, and the way that you implement your functionalities, your definitions of your C++ programs, that needs to go back and forth between the two sets of learnings and skill sets and reference material. So C++ is kind of unique. I want to point something else out here. The C++ is kind of unique as an object-oriented programming language. There are lots and lots of object-oriented programming languages out there. And C++ is kind of different, number one, because it directly is a descendant of C, but there are a lot of others that are just by default and by lineage purely object-oriented languages. So there are like hybrid object-oriented languages, of which C++ is one. And then there are pure object-oriented languages. If I recall, one of the pure ones is Java. Everything is an object and a object-oriented idiom and syntax in that language. But what's important here, I wanted to point out, is that C++ is a hybrid. And so things can get kind of muffled and and strange in C++ land as far as really understanding, am I really doing things as an object in an object-oriented programmer way, or am I still over in procedural land with C? And things can get very confusing. You can really what's called shoot yourself in the foot whenever you migrate from C to C++ because of that inconsistency. And you can, in other words, you can do the same type of thing in some ways with C, excuse me, in C++. You can either do it more or less in a procedural way or in an object way. So I just wanted to point that out, that C++ can be very confusing that way. There's additional functionality, naturally, in the C++ standard library that you need to be aware of. And there is something called output streams in C++. Now, that is something that is basically non-existent in Arduino because of that non-operating or I/O support. But output streams are in C++ what's called CN and Cout functionality. And what that has to do is it's more or less an augmented, more feature-rich version of printf and scanf. So printf and scanf on the C side has to do with the way that the operating system and the language and the PC hardware process strings and the way that data is being taken in from, say, the keyboard or displayed on the monitor. That's where a lot of this CN, Cout, printf, scanf kind of thing comes into play. And so it's a glorified, more feature-rich version of printf and scanf. That's kind of what output streams are. It's really not. It's a weird term, but it's really that simplistic. Another C++ concept. Again, this is getting into the rudiments now of what object-oriented is all about. Is what's called classes and methods. So a class is literally an instance of a excuse me. A class is a definition of an object. And when an object is, when a class is instantiated, it becomes an object. And an object you can literally think of as an object as like a person or a dog or a cat, some real physical thing that is part of your program. And part of class definitions are methods. And one of the big distinguishing features between C++ and C has to do with the way that functions or methods in C++ are merged in with data in C++. So a class has both functionality and data all contained within it. And that's where a lot of what's called encapsulation of data and functionality come into play. And that's one of the key components of an object-oriented methodology is how classes and methods and data are all put into one. Okay. Another key component of C++ are constructors and destructors. Again, I'm not going to get into really what those are, but in Arduino, a lot of this stuff is present, and you can implement functionality with them. There's going to be an exception to that that I'll get to in a second. But classes and methods and a lot of the object-oriented methodology of traditional and standard C are available in Arduino. They're not really advertised, so to speak, until you actually get in and you start looking at the standards and other websites for Arduino implementation. And I'll get into that stuff in a little bit. There's also what's called inheritance and composition. There's also what's called polymorphism. There's also templates. Okay. So those are all key. I'm not going to get into what those mean right now. Okay. Or really, I'm going to ask all of you to be studying those kind of things on your own. But those are key concepts in C++. The thing that is not present in Arduino is what's called exceptions. So exceptions are a way that a traditional C++ program and other object-oriented programs as well process and handle your program when something bad happens. Say, for instance, if you divide by 0, which is a giant no-no in the programming world. Okay, so if you try to do that without an exception handler, the program will literally crash. Okay, and whether we're talking about with an Arduino program or a PC runnable program or server runnable program, things will crash because the code doesn't know what to do and the PC or the hardware doesn't know what to do. So exceptions, regrettably, are not implemented on Arduino. And again, you'll want to consult standard C++ good textbooks, and I've provided some of that stuff, some of those ideas to you before in the materials that I provided. But you'll want to what it is I'm getting at here is that so much of, and this is something that I don't think is stressed really in Arduino learnings, at least other ones that I've seen, is that a big part of your learning and your knowing what you can do with Arduinos is based on core standard ANSI, C, and C++ languages. So that's what it is. I keep reiterating on this. That's why I think it's so important for us in mastering Arduino to also master C and C++ in the PC world. Okay. Okay. So let's just review basically some things about standard C, other things that are not formally supported by Arduinos, but are present in standard C and C++. Okay. Okay, so I'm going to read out some key concepts here. Okay, so Arduino programming language is based on C and C++, but with some key differences and limitations, primarily due to the constraints of the embedded microcontroller environment. While Arduino supports a subset of C and C++, it omits features that require an operating system, file system, standard display, or keyboard, and instead provide Arduino-specific functions for hardware interactions. That's a key concept in moving from PCs into Arduino. Okay, so here's a breakdown of what's missing and why. Standard C and C++ library functions. Remember, we talked about the standard libraries. Many standard C and C++ libraries that rely on operating system features like printf, scanf, file input and output operations are not directly available in Arduino. Okay. Point 2, operating system abstraction. Arduino doesn't have a full operating system, so functions that interact with the OS are absent. Point 3, file system access. Direct file system access is not typically available on Arduino boards, as they are designed for embedded applications. Point number 4, standard input and output. Standard input and output streams like standard in, standard out, standard error are not directly supported. Next point, dynamic memory allocation. Due to the limited memory on Arduino boards, dynamic memory like malloc, GNU, etc., is often discouraged and can lead to instability because of memory, what's called memory leaks, and literally running out of memory. Things again can crash in strange ways in using dynamic memory. That's why that point is made. There are also missing or limited. Well, let's see. Okay, so the next concept is exceptions. I'd already mentioned this before, but this is part of the dialogue I wanted to outline. Exception handling, specifically what's called try and catch blocks in C++, is not supported. Floating point operations, okay? While some Arduino boards support what's called native floating point operations, they are often limited and can be resource intensive. Next point, string functions. Some standard string functions may not be fully implemented or optimized for the Arduino environment. Okay, so here's a set of Arduino specific functions and features that are supported, okay, on the Arduino. There's what's called, and we've talked about this before, what's called the setup function and the loop function. Both of these are what's called in standard C and C++, the main function. Okay, in other words, where program execution starts. In Arduino speak and definitions, their main has been redefined, at least for the Arduino IDE, as setup and loop. Okay, Arduino programs are structured around two functions: setup, which runs once at the beginning of your program, and loop, which runs repeatedly. Okay. Next is hardware interaction. Arduino provides functions like digital read, digital write, analog read, and analog write for interacting across the hardware pins for I/O. Okay. Next are libraries. The Arduino IDE includes a set of libraries that provides common functionality for interacting with various sensors, displays, and communication protocols. Okay, so why do these limitations exist? Resource constraints is the primary rationale here. Arduino boards, especially the smaller ones, like Uno, have limited memory and processing power. Next is just a general embedded nature of these boards. Arduino is designed for embedded applications where the primary focus is on controlling hardware. Okay? Another point is simplicity. The Arduino environment aims to simplify programming for beginners by abstracting away complex hardware details. And that is really seen within the Arduino IDE. There's tons and tons of simplifications and things that the Arduino behind the scenes takes care of for us as programmers. So one final point is, how is the Arduino programming language different from C? What makes Arduino language different to standard C and C++ is that a small number of standard functions and features have been removed because they consume too many resources, and other functions have been added instead to allow reading and writing of the pins, etc. I went through those Arduino specific functions and features. That's what that statement is referring to. Okay. All right. So just a little bit more here to finish us up for today, and then we'll get on to questions and the transition from brain dump of a water hose to you guys asking questions. All right. So let's do a little bit of review now of Arduino language. The Arduino language that is in general proclaimed, and all of the updates and the current version of Arduino language is provided at the website called arduino.cc. Likely you guys have already accessed that site before. So the Arduino language is broken up into three. key areas. There are functions, there are variables, and there are structures. Remember before I was talking about the idea about syntax and idioms? Well, in Arduino, that's where the syntax and the idioms come into play, is via functions, variables, and structures. Now, what it is I'm talking about is directly readable and viewable off of Arduino.cc in the Arduino library reference manual, I think is what it's called, or the Arduino language reference manual. And that's available either as a PDF or clickable links off of the various sections on Arduino.cc. Next point is that structure, okay, that's one of the three. Structure represents language, syntax, and idioms, okay? Variables represent data types, like like char, like int, etc. Functions represent C functions and C++ methods, okay? Now, how do you tell in that documentation if you're looking at a function or a method? Okay, methods will include a dot in the way that it is displayed and used when you're writing a programming statement or documented in the documentation. So an example of this is what's called the serial class. Serial class is used for the standard serial communication port. So there's a serial class that's defined for Arduino. And you'll see that in the library, in the language reference for Arduino, you'll see that is in capital S. So serial dot begin. So that dot automatically means that you're talking about a method. So you're looking at a object-oriented or a C++ structure is what that means. That's what that references, is an object that's going to be created using that. So you're in object-oriented, aka C++ land, when you're looking at a documentation item like that. Functions don't include any dots. For example, the delay function. The delay function is part of the regular array of, no pun intended, and not literally, array of functions. So delay will literally just be declared and documented as delay with right and left hand brackets. Okay. Okay, so next point. Some behind the scenes information on the Arduino IDE and the Arduino library. Okay, so when you install the IDE and computer drivers that hopefully all of us have done at this point on our programming machines, you also get the Arduino code base as well. With it, that's the way that the whole package comes to you for utilizing in programming. Files or sketches in Arduino lingo. Layout is let's see. So the files layout of main is instead replaced with the loop function and the setup function. So in general, within the Arduino IDE, you do not declare a main function. Instead, you declare loop and setup. Okay. Also, a big difference between the IDE and other programming environments that are supported for Arduino is that, remember I was talking before about .c, .h files. Okay, that's to do with for C language. And then for C++, there's what's called .cpp files and .h files. Now, this is talking about standard C and C++ file structures for the way that you actually build your programs and that are eventually created into binaries during the compilation process. But in the Arduino IDE, if you go in and you start looking whenever you're creating your projects utilizing that IDE, you're going to see weird looking file extensions like .ino. In general, within the IDE, Arduino IDE, they don't utilize .c and .h. Again, this is part of the abstraction and the simplicity that the IDE provides to us, but it can be very, very confusing if you're trying to understand, if you're trying to translate what you've been learning and will continue to learn in C and C++, and then looking at what it is that is going on behind the scenes within the Arduino IDE. To me, it's a poor design, to me, but it's the de facto default computer programming IDE for Arduino. So we need to talk about it. But to me, it's very, very confusing. So that's one thing that if you start looking at the way that the projects are defined, the downloadable that's generated, and then eventually downloaded into the board, things are going to look different. And one of the main things is that .ino file instead of .c and .h. Okay. Tool chains. The tool chain is a modified version of a standard open source compiler package called GCC. And the Arduino variant of that is called the AVR because Arduino's primarily the lower generation or the minimal functionality Arduino boards are all based on at-mill AVR processors. Therefore, the Arduino port of GCC is called the AVR port of GCC. And that contains the compiler, the assembler, the preprocessor, tools needed to convert object code into a single binary, which ultimately gets downloaded onto the board. So all of that is on the kind of like on the back end, which is accessible to a degree within the Arduino IDE. That kind of stuff is there that's going on behind the scenes that is generating the code, working with the code. Okay. And then there are tools to upload the binary onto your board, automatic within the system, both on the board itself and via the USB cable, and then the IDE. Code base elements. There's what's called the C and C++ core, supporting the syntax and the idioms. So these are part of the IDE, okay, that comes in that Arduino code package. So there's the core itself. There's the C and C++ standard library. It supports various functions and methodologies. That's all part of the code base, okay? And then if you dig down within the IDE, as far as the settings, the project settings, you will identify the tool versions and the drive locations that the IDE is utilizing to access the GCC package of tools. So that's an important thing to be noting. And remember that the Arduino manufactures and sells boards, not processors, like the AVR processor. So each board is paired with a specific processor and peripherals and support hardware and connectors supported by that processor. So in general, that's the way that you need to think about an Arduino board. Has the processor itself, whether we're talking about AVR or we're talking about a newer, more powerful processor, is that there's the processor, and then built around that is the support hardware. And that's what comprises an Arduino board. Okay. And then all the attachable IO that is available. So to really understand Arduino programming, you not only need to learn Arduino C, libraries available, but also study what's called the processor data sheet, plus the design layout of your board. Okay. And then when you want to know additional functions that GCC provides us, you need to reference both the AVR processor datasheet and what's called the AVR libc reference manuals to clarify what is supported. Now, I'll be providing you with a set of URLs whenever I'm through speaking here that will help clarify all that, and we'll review that kind of what it is I put into the chat a bit. All right, so let's see. Yeah, so I think this is going to be the last section here. I want to talk about as a side, as a support part of what it is we've been talking about today, an overview of libraries, specifically the pre-written ones, the ones that are provided to us as programmers. Remember, we were talking about the standard libraries of C and C++. Now I'm talking about libraries that are available in Arduino. Okay. So official libraries included with the Arduino install distribution that come with the IDE. These are easy access, pre-installed right within the IDE. So that's one set of libraries. Then separately, there are what's called contributed libraries. And these you must add yourself as you find them, as you have accompanying hardware that utilizes those libraries. You must add those yourself to the IDE. And these are contributed by the user community, not part of the IDE core and what comes pre-bundled when you do that install. And these libraries, the contributed libraries, are indexed off of the arduino.cc site, specifically docs.arduino.cc/libraries. And then separately, there's another group of libraries that are pre-written. And these are sitting on on GitHub and other sites, but are still written by a user community. And you find these via Google searches for a particular part or function. So the important thing is, so let's talk again about the three distinct areas of pre-written libraries. There's the official libraries that are included with the install distribution. There is one level of contributed libraries that are directly available off of arduino.cc. And then lastly, there are separate that arduino.cc does not recognize. There are other contributed libraries that are out there. Okay, so important use notes. You use any of these at your own risk. Remember, these are provided to us. They are not written by us. So we really don't know for sure where that code is coming from, how much they've been tested, etc. Okay, so that's why I say you use at your own risk. But the official libraries, the ones that come included in with the IDE package, have likely been completely, fully tested to find and fix bugs. And they are likely very stable and a great resource and a trusted resource for us to use. Okay. But other libraries may not be fully tested. So you need to look at, and in ensuing meetings, we'll be talking more about using and choosing libraries and some of the nuances there. But you'll want to look at library documentation to really understand, is this something really that I really want to take a chance and use? Or is it just a piece of junk that's sitting out there? Okay, so that, believe it or not, that is the content that I wanted to present today. And what I'm going to do, I'm going to go ahead and put those let's see. I want to put those URLs in the chat for us here. Okay, and then I'll open things up for questions. All right, let's see here. So specific reference sites. Okay. All right. All right, so Control V. Okay, so before I open this up, I wanted to comment a little bit about what I just put in the chat. Um, so docs.arduino.cc is the main locator point for hardware documentation, the language itself, the example code that's available per part and per board within the IDE, and also reference materials on how to use the and program with the IDE. So that's kind of the go-to hub for everything that is associated in general with the boards, the pins, the layout of the boards, and also specific to the IDE. Then the next URL that I've got there, that github.com based URL, that's the okay. So things with Arduino, as far as code and hardware, regrettably, is a very convoluted and top-down set of structure of complexity. And the next level down off of the Arduino IDE and the Arduino language reference is the AVR libc. Okay. So it's really the C and C++, but they call it libc. Okay. So whenever you want to have access to other that comes with the GCC port of in AVR of C and C++ functionality, it's this site here that contains all those definitions and the way to include the .h files, the .c or C++ files to actually get in at a lower level down than what the IDE provides for additional functionality. And then to support that, there's the next AVR libc link that I got there contains more documentation at more of a lower level programmer standpoint than what the preceding URL provides. And then back into the Arduino language and IDE, if you go over to docs.arduino/libraries, that is the whole Arduino.ccc composite collection of built-in and community libraries that are supported directly in the IDE. And then lastly, the last URL is an advertisement, so to speak, for the location for the spring robot contest that I talked about at the very beginning. It's going to be held on May 31st. Okay. And so that's the composite of the information I put over in the chat. And I hope that I haven't overwhelmed any of you. But I did. What I delivered here today is great information for utilizing the IDE and knowing really what's going on with Arduino. Okay, so I'll shut up and let others ask questions, contribute, and at this point we are opening things up for Q&A and for the workshop time. Okay.
I guess I'll start. Donna,
Yeah. Oh, yeah. Okay. I'm sorry. Yeah. Go ahead. What were you going to say?
for those that are familiar with C implementations, is there anything equivalent to make, or is that pretty much just hidden?
Yeah. So it is hidden. So yes, make is available,
Hmm.
and it's being that it's part of the standard GCC implementation. But what's bad if you're just using the Arduino IDE is that all of that is hidden from you. There's so much that's hidden in using that IDE. And that's one of the things that as we go forward, that we're going to be learning and migrating about more migrating to what I call the next level of Arduino IDE called Platform IO. And with that, you can do so much more. You have the full access to the more standard way that C and C plus programs are created, compiled, written, and maintained, and ultimately shared out with others than what is available in the IDE, Arduino IDE. Okay. So yes, to answer your question or make your uh, comment on your point, Doug, Make is supported, but it's only available in these other types of either if you do raw programming and then your own uploading onto the Arduino board, which is possible, by the way. But it's so much easier if you use a pre-built system like Platform IO or uh, the default Arduino IDE.
And
Okay.
have you seen any workarounds to the lack of exception handling?
Let's see. So there are some. No, I don't think that I have.
Hmm.
Other than if you do. Oh, let's see. So no, there is one. There is one workaround, but it's quite rudimentary. Is one of the things that's available in C and C++ is a function called assert.
Yes.
Okay, all right. So you can utilize assert on Arduino, and you can do some catch of problems
Oh,
utilizing assert. Okay.
okay.
And I remember that I also didn't include files that I wanted to provide you about for the project time today. There were remember during the advertisement or the preparatory stuff that I recommended for today's meeting. There were a whole bunch of recommended hardware and parts that I suggested that you get. And so to be able to experiment with any or all of those, I'm going to be providing a set of, I think it is 9 mini projects that utilize that set and that get you more familiar with the C functions, the C++ objects, and the hardware, and constructing projects hardware and software wise, utilizing those parts that I recommended. And so I'm going to go ahead and put those, it's a set of PDFs, and I'm going to go ahead and upload that stuff into the chat. Let's see. So did all 9 of them get in here? One, two. I think there's 9 of them in here.
So how
Uh,
do we get those?
okay, so all of those I believe came from the same book, Doug, that you and I talked about in the Discord server,
Okay.
of where the last month's exercises came from. Let me go ahead and grab my book, my physical book off my shelf here and show you.
So I guess what I'm
They all came from this book, the Arduino cookbook. Okay. And this is a great kind of for all of us here. This is kind of a great book to have for Arduino projects and the basics of how to use the Arduino language and also programming advice in utilizing the Arduino IDE. Well, this is a great kind of reference book.
so I'm asking a Zoom question, I guess. I'm used to clicking
Oh,
a URL in a chat,
okay.
but
Well, there's no you. Okay, so okay, so let's see. So I think
it
if
says like a
if
click.
you're, so first of all, if you've got, of course, if you've got to have the chat, of course, window open. But
Right.
if you click on, oh yeah, here, there's a download button that's there.
Click to
So
download.
if you click on that down arrow with an underscore on it, that's going to allow you to actually download the PDF to your computer.
Hover
Did
the
you
mouse
find that?
inside the PDF.
Right, yeah, that's on the it's up on the upper right-hand corner of where the PDF image and text is. That's where that downloadable is. Yeah, yeah, okay.
The arrow doesn't show unless you hover your mouse inside the.
Correct. That is very true. You have to hover your mouse on the image itself.
Do you suggest the cookbook for like beginners so we can learn Arduino?
I'm sorry, I didn't understand your question. I swore I heard you say QuickBooks.
Yeah,
I know you didn't say that.
no, the
I'm sorry.
cookbook
Please
you
restate.
showed us. Remember the cookbook you showed us? The book you picked up?
Oh yeah. So okay, yeah. So it's called Arduino Cookbook. Um, and I'll go ahead and put that into the chat also, as far as the author and the ISBN. Okay.
Yeah, would you suggest that for like starting out with Arduino?
Yes. Uh-huh. Yeah. It's a great start out book for getting going on Arduino. It goes. It really presupposes no prior knowledge. Okay. Okay, so there's the information on the book that I was referencing.
Think.
I picked it up at the library, and I think I might get my own copy now.
Well, you know what's so great too, Graham, and everyone, is that you can get, being that these books that I've been repeatedly, uh, the specific books that I've been recommending to all of you, is that they're available completely free via electronic book that's available as PDFs. You can readily get these if you do a Google search, like on this Arduino cookbook. Do a pull up your favorite browser and launch Google, and then indicate the name of the book and say free PDF, like something like that behind the title, and you'll get, and you can, I mean, they're freely available because they're such old, they're considered old books.
Okay.
And so a lot of the in general, I nowadays, because textbooks are so expensive and books are in general expensive, physical books, is that I try to get, when I want to learn something new or have good quality reference material, is I automatically go online and do a search and find out if that book is available for free someplace.
Now, I
Okay.
mentioned on the Discord server, though, that the version that I found online is a different version than the version you
Oh, okay.
got
Well,
your first example from.
okay. I thought I
What
thought I
version?
thought that I've been able to find
It's the
the
second
same one.
edition, maybe.
Second?
Yeah, I
I'm not
thought that
sure
I
which is
thought that
which.
I'd been able to find that before. But see, okay. In fact, the book that I held up, and I think that I gave the ISBN for, is the original version.
Oh,
And
okay.
that one for sure should be available online.
Yeah, I have the second edition, I guess.
Okay. Well, the same. I mean, it's the second edition should be even have more
More, yeah.
examples.
But the pages, the page numbers
Right.
don't.
Yeah, the page numbers are going to be different. That's true.
Yeah, yeah.
The figure numbers were different.
Yeah.
I guess there's a fourth edition, maybe.
Doesn't like the spaces. Ah, okay. I found the problem that I had with the
With the
serial.
plotter? Yeah,
Yeah,
with the plotter.
the
Okay.
problem is I had a space between the name of the value and the value itself, and apparently it doesn't allow that. Um, I know I went back to my original, the demo, and it didn't have any space there. So I thought I'd try that, and that fixed it.
Mhm.
Now the next question I have is, can it handle more than two variables? So I'm going to go back and I had commented out the third variable, thinking that might be the problem, and we'll see if that works.
And if you want to, Doug, or any of us, do
Mhm.
share screen, you can do that. So
Okay.
it might help to actually look at what you're looking at.
Oops. Let's see what this does here. Yes, I have. Oh, and unfortunately, oh, I see it. It takes it a while to figure it out. So I have now three variables. Let's see if I can get them to actually do something. So I have this what is this kit called? The most complete starter kit mega project.
Okay.
That's how I got my Arduino Mega.
Right.
And I have the first 13 um projects, or they call them lessons, I guess. I have the
Mhm.
first 13 all implemented on my proto board here.
Mhm.
There were plenty of extra ports on the Arduino Mega, so all I
Mhm.
had to do was plug my hardware into different ports and change the program to point to those ports.
Mhm. Mhm.
So I have the temperature sensor, the servo, the ball switch, the membrane keyboard, the um, ultrasonic transducer, or well, transceiver, I guess, and the joystick all hooked up here. And there's an RGB LED in the kit, and they have you put that in and drive it with various combinations of red, green, and blue. And then the next project was to put in a button and use it to turn an LED on and off. Well, I figured, well, I'll just put in 6 buttons and turn red and green off, or red, green, and blue off individually. But there were only 5 buttons in the kit. So I thought, okay, well, I'll put in 4 buttons and have a red, green, and blue button, and then a shift key that decides whether each of those buttons is going to turn the light on and off. All of that's worked very well. Here. Oh, now my joystick is working. And let's see. I'm not sure it knows what to do with the button though. But let's see if I can. Let's see. I can. So how does one share the screen?
Oh, yeah. See, so there's at the bottom of your Zoom screen, there's a big
Oh,
green icon and it
yeah,
says share.
yeah.
And then you click on that icon, and then there's another dialog box that comes up. And then you can either choose to share your entire screen or an individual application that's open.
Let's see. If I do just my analog joystick, then it's not going to see this. I think I just want to do the whole one.
That's usually what I recommend.
Yeah, it's numbered that way. I see it actually puts numbers on the desktop so you can tell. Okay, and then share. So there we have so you can see my uh docs in the background there. The windows from the Zoom have made it through. Isn't that interesting? And then we have my program running there, and
Yep, X, Y.
so the program is a mashup of my analog joystick, which is one of the examples uh, from the kit, and all I had to do is make little changes to the loop function so that it adhered to the format required by the serial plotter. So what all did I need to do? Well, I needed to make sure that I had no spaces between the beginning. Let's see, can you see my mouse?
Yep.
Between the beginning of the label for each variable, uh, so anywhere in that, there can't be spaces. I had another version of this where I had 2 words in there, and that space caused it to quit. So, and then in this one, I had a space after the colon, and that caused it to quit. So just take all those spaces out, and then I had to, in the original, they had a carriage return in here, and you have to have all your variables on the same line. So I changed that to comma space and on each of these, and the dash was already an x-axis, so it was just the space at the end here, and y-axis. And apparently, it will take any number of variables because we have 3 running now, and it automatically figures out what scale to put here on the left. And so if I move the joystick now, you can see it is actually plotting. But when I push the button, it's not doing anything. I think the green, yeah, it says switch is the green one, and it's not hearing it. So I'll have to debug that at some point.
Okay, cool. So
And
I'm not familiar, so forgive my ignorance here, Doug. But could you educate us, or at least me, as far as where this I mean, is this serial plotter that you're talking about? Is that
oh,
something that's automatically included with the IDE, this newer version of the IDE, or what?
yes, the version of the IDE that I installed
Okay,
uh, has these 2 icons here on the top of each
okay,
fetch window, and this is the one the serial monitor.
right,
And you can
okay,
see it
right,
going at the bottom here. And
okay,
then
right,
the serial plotter is this one.
okay,
So
all right, cool, all right.
do that over again here. If I turn this off now, and I can turn off the plotter, or I mean the printer, and then I don't need to have them both going. I can have just the plotter going, I believe. Let's see if it
Mhm.
and yeah, it's still going pretty fast. Oh, the other thing I took out of the original demo was I think they had a oh, you can see it here commented out. They had a delay of 500 milliseconds, and I just
Hmm.
commented it out to
Hmm.
so that it would get more often a value, because
Hmm.
there's no way. Well, basically, I think the rate at which the plot progresses is probably directly dependent on the rate at which your lines come out. But
Hmm.
now, um, when you use the printer, I'm trying to remember. I remember there was a step where you had to tell the serial monitor. Oh, here it is, right here, 9600 baud.
Oh, right,
Um, and so that matches up with the 9600 in the call to serial begin in the,
right, exactly.
but
That's right.
there was no such matchup. Oh, here it is. You can see it. 9600 baud,
Okay, right. Yeah, there should be.
also
Yeah,
a window on
right,
the plotter. So we
right.
could try that at a higher rate just to see if it plots quicker.
Yeah, right.
I guess you'd just be pulling the joystick that much faster.
Right. Well, we're just going through this loop function as fast as we can, and really the limit right now is, well, how long it takes to actually do these
So,
digital reads, but also,
but one thing to note, Doug, as far as that, say, like upping the ante as far as the baud rate for any of these, you have to reference for any of us for any of this hardware. You need to look at what the specifications, what the ranges of the baud rate that is compatible with that particular part. So you may need to, what I recommend that you do, Doug, for this joystick and the other parts that you've got hooked up to the serial plotter, is that you look specifically at the supported range of baud rates that particular part is allowed to communicate with. Because, say, for instance, I know for sure with GPS boards, etc., that you can interface directly with the Arduino, and then a lot of other boards and parts, is that they have a specific. Of course, there's the default baud rate, but then they also specify for the spec what the other values can be, what are supported by that part. So that's a very important characteristic to be looking at.
right. In this case, the joystick is an analog joystick.
Right.
It's
Right.
just going as fast as it can through this code here, but it'd be the calls to serial print that would be using the baud rate that we've set it to. And well, I would expect just about any baud rate to work because we don't have any physical hardware here doing that, right? Let me think about that. It doesn't actually make it to any port pins. The the sending of serial data is virtual. It's all in the code running on the AT Mega. There's
Hmm. Hmm.
nothing coming out of a port and going back into another port. So I would expect to be able to speed that up, but I don't need to
So
do
it
that.
could be limited by the clock rate of the microprocessor then.
Oh yeah.
Right. Right.
It
Right.
could even be that, depending upon how they implemented serial, it might be that high baud rates are uh, deviated from the standard actual rate because of the base clock rate of however they're implementing that baud rate. In
Right.
fact, it might even be that the baud rate doesn't mean much when you're not going off chip. I don't know. They don't have to be um, using uh, a clocked serial protocol in the chip itself. It could be that only if you get to a UART or out to a serial port that baud rate even means anything. Well, let's see if we can do it.
That's
Just
what I was wondering, if the serial print itself might be limited to a particular speed.
well, let's see. So what we have here, well, I'll go to just twice. So 19200 goes to garbage, and then we change our source code. There's 19200 and build again. And there we are running twice as fast. Now, if I call the plotter, it doesn't know what to do. Oh, it thinks it does. Oh, it automatically got the 19200. So somehow it automatically updated that. That's interesting. It may have gotten it from the setting of the serial monitor. So let's see if I move this now, it'll come out twice as fast. Yeah. Anyway, so that was fun.
Yeah.
No. So I did forget a couple of the peripherals I already have. There's also a um what do they call it? There's two speakers. One of them,
Oh, is a piezo speaker is a traditional.
yeah, but there's two of them. One has onboard electronics, and the other one is just raw.
Yeah.
Oh, okay.
The one with onboard electronics has a pitch that it puts out. And so all you can do is like turn it on and off to make pulses or something. And the other one is just driven directly by the digital output of the Arduino. And so the example program came with a header file. I think they actually did call that .h. So it is possible to use .h files.
Yeah, yeah, it is possible. Yeah, I wasn't saying, Doug, I'm sorry if you took what my comment was. No, you can use .h files in the Arduino IDE. What I was saying to one of your earlier comments is that you can't directly use make. You can't create the
No,
make
no,
file,
no, but you did
within
mention
the IDE.
in your
And
presentation.
I was just saying that the default file
Yeah.
extension used by the Arduino IDE is a .ini file. They don't by default use .c or .cpp or .h files, but you can incorporate those into your Arduino IDE projects. It's not the default.
If you had a multi uh source file setup
Mhm.
where you needed to use a common header file to communicate
Mhm. Mhm.
can you put those multiple those definitions in a .eno file and then include it?
Well, let's see. So if I'm hesitating because I'm trying to remember the way that the Arduino IDE recommends this.
Oh.
But it seems to me that the default, the way that the IDE recommends setup of your projects is that literally everything is within one file.
Oh,
Okay,
really?
that's their traditional. But the thing is that what you can do, and what I recommend, like to do with good programming style, is that here on out that we utilize the concept. We still need to have a .ini file. If you're going to use the Arduino IDE, you have to have at least one .ini file, and that's where setup and loop is handled. Okay, and declared and used, referenced, etc. Okay, and then you can have additional .h files, .c, and .cpp files all within your project of this IDE. And so what I recommend that this is part of what's good or what's recommended for good C and C++ programming style, is that we use .h for doing all of our definitions of our structures, our unions, our class definitions, all that kind of stuff should go into .h files. and then the actual code itself and declarations of instantiation of objects, calling of functions, all that go into .c and .cpp files.
Oh, okay. So you have to tell it where those files are, or does it just come?
Yeah, so you can, if I recall, I'm trying to remember how that's done in the IDE.
It's almost like you would be making your own libraries, I guess.
Yeah. Well, right. And that's something, Graham, that we'll be getting into as far as how to create, write, and compile all that for your own libraries, and then subsequently include those in to your other projects. But yeah, creating your library is kind of a separate concept, but in a way it is related, because uh, libraries, whether we're talking about uh, ones that are built in with the IDE or a community library, are all based on .c and .cpp and .h files. So yeah, in a way, you're right, Graham. But it is as then a little step further out for an additional compiling step, all that kind of stuff, to actually take those files and then build a separate usable library. But yeah, it's all kind of tied together. It's just an extended step there.
For those who didn't come to today, of course, you can always just run it. I don't know. Well, okay, so you're going to put this on YouTube, right?
Correct. Uh-huh. And then I'm also going to be putting the files and the reference URLs onto Discord, like what I normally do. So all the textual content in general goes into Discord, and then the raw video file goes up onto YouTube.
Right.
John, you've been very quiet. What do you want to say or contribute?
Well, I can show you what I've been working on.
Oh, okay. We'd love to see that.
I'm not using an Arduino. I shared on Discord a board that I purchased. Here, I'll share this screen here if I can find it. Oh, what is going on here? Okay, does this thing do weird when you're using two screens?
Yeah.
Maybe.
Let's see. Remember what Donna told me. You go to the bottom here and you have a little share button.
Yeah, I did that, but it's like it's not showing. Okay. It's not showing what I want to share.
Oh, well, just pick a window. It put numbers on the windows. Or not the windows, the screens. I had two screens and it put a 1 on one and a 2 on the other.
Maybe this one. I don't know what I'm sharing. We'll see what comes up. Well, that's definitely nothing.
I can't help because I never use Zoom with multiple screens, so I can't advise.
Darn. Okay, let me try and move this over here and see what happens.
Something's
We're
going.
getting something, no?
There we go.
Can you see the whole screen?
Maker M Sumo board functions top is what we're
Data sheet, yeah.
Okay. So do you can you read what's on here?
Yep.
Oh, okay.
Yep.
So this is the board I purchased for my mini sumo, and I'm really liking it, mainly because it's taking everything I need to use for the robot, and putting it all on one board instead of like buying a microcontroller and then a motor controller and all the separate
Mhm.
parts together. So I'll kind of go through it really fast. It has a lot of these ports here for sensors, like we have left sensor here, right sensor, and then three in the front, and then extra GPIO ports that you can use for whatever, and then these little edge sensors, and also it has a servo port and a power switch, reset button, and a start switch, which is having them separate's nice. Oh, and also this mode switch down here. It has the ability to have 8 different modes with those three switches there.
And
Nice.
that's something that your program reads and decides what to do.
Yeah, so you could like set it up with different strategies. You have like 8 different strategies if you wanted.
And you have
This,
left and right motor test buttons. That's pretty cool.
yeah, so it'll switch either way too, forward, backward. It has a little extra port brought out here for this start module. So you could actually hook up an infrared receiver on here, and then use like a TV remote control to start it instead of having to push this button here. So
So where's
So,
the where's
sorry.
the processor on that? Is it on the back? Because it
yeah, it's on the back. Here's the
Oh.
back. Let me see.
And so which processor is on there, John?
It's the same as the Arduino Uno.
Oh, okay. Oh, okay.
328P. Yeah.
So can you program it through the IDE then?
Yeah. Yeah, sure can. Here's the
Nice.
Oh, okay, the USB.
using
Yeah.
the micro USB port there. So yeah, just using the Arduino IDE. The back side looks like this.
There we go.
So yeah, it's got the a little speaker down here.
Write your name here.
PCO speaker. So, and it had these also. So if your robot you wanted to, you could slap this board right on top of the sensors, but they would have to be in those positions.
Hmm.
So I ended up removing those
Hmm.
because they hung down quite a ways. But yeah, I'm liking it pretty good. One thing
Nice.
I did discover recently, just by chance, I was wondering. It seems like they didn't actually give you access to the I squared C on here.
Oh.
So you're a little bit of trade-off there, I suppose.
Hmm.
Can you make use of the ports that you didn't you decided not to use?
Yeah.
Flash
So
yourself though.
yeah, let me go back up to the top. So I'm just using this one here, the left and right. I'm not using the center one. I'm taking the left and right and kind of overlap the view a little bit. So center is actually when both of them are seeing the object. So I have this one open, and then this one here I'm not using, and this one's up. So yeah, I have several of them not used.
And then there's two for the idea about other IO
Right.
pins that are not directly called out either on the front or the back of the board. Then you've got the two GPIO ports then separate.
Oh, the ones on the back of the board?
Oh, well, no, I'm talking about on the front here. What it is we're directly looking at. There's two GPIO
GPIO 1 and
ports.
2. Yeah.
I don't know what those ports are in reference to, especially to do with in reference to the Uno.
Oh, okay. So,
You know what I'm trying to say? In other words, I know that that doesn't help with your I squared C, etc.
yeah,
Protocol,
there we go.
but
So,
it does address other I/O that isn't directly used by other dedicated ports that are on the board, is what it is I'm getting at.
exactly. Yeah. So yeah, they're they call it a general purpose one. So it's hooked up to analog 2 and 3.
And analog 2 and on analog 3. Yeah.
Yeah.
So how much was that board worth?
Say again?
How much is that board worth?
Oh, it cost $27.
Oh, that's
Pretty
not.
cool, huh? Yeah, it's like so I got an Arduino Uno there plus the motor controller and all the little I don't even just solder anything. I can just like screw the wires right
Yeah,
in.
you just right. Yeah. Wow. And
Um,
where did you purchase that from, John?
Through through Robot Shop.
Oh, okay, the robot shop. Oh, okay.
Yes.
Yeah.
Mhm.
They're up.
Yeah.
Okay.
Last
They've
I
been
looked,
around
though,
a long time.
last time I looked, they were out, but they can. So I'm not sure what's going to happen.
Yeah,
Because
especially with these imports and
yeah, exactly.
I mean I'm sorry, I mean tariffs kind of stuff.
Yeah, yeah. Let me see if I can bring something else up since that worked. Let me try and drag this over here. Oh, I'm gonna have to. Okay, stop that share. And let's see. Okay, I'll try this one. I'm getting the hang of it. So what it does is I click on share and it gives me the option of which screen I want
Right.
to share from. So, so here, Doug's already seen this because we did a bunch of them at the Hobby Expo. I brought this there, but so far I've gotten this to actually track an object. So let me see. Can you guys see the screen?
Yep.
Mhm.
Okay. So I'll play it so you can see what happens here. Turn down the volume. So, so yeah, it's doing pretty good
Yeah.
as far as finding that. And I could actually, a little while ago, I was trying it with just throwing a pencil down there and it would actually pick up the pencil on the ground. So,
Mhm, mhm.
So what I was just noticing is it stops as soon as it sees it, but you could imagine as a next step that it should move a little bit either way and figure out its extent, right? So because if it stops as soon as it sees anything, it might get just the left edge or just the right edge.
you I think the next step, I will be trying out some different motors and just to see a balance between um, how much, because right now I'm running pretty fast at 50-to-1 ratio gear motor. So, and when I did the code, it's like out of 255, I'm at 47 right now. You saw me at 47, so I'm like, that was just pretty fast for. I
Oh.
guess.
And which so that kit for I'm sorry, that purchase of that board that you were showing us. So did
Uh-huh.
that come with a platform too that you purchased, or is that just your own platform that you implemented your bot on with the
Yeah,
board?
Yeah, I built the platform for it.
Okay. Right.
Mhm.
Okay. Cool. Good job.
Thanks.
That's good progress so far on that.
The goal, of course, is to beat Thin Man. But
Right.
um, maybe if you guys want to build one too, that we can.
Oh yeah, I'm in the process of doing that, John.
Oh, good.
Maybe to wax you out of the ring. Oh, do you have anything else to share with for us, John?
Nope, that's all I've been working on, but robot wise anyway.
Hmm. Graham and Mickey, do you have anything that you want to share or ask or contribute?
Uh, I got a USB host shield on order, so I'm waiting for
Oh,
that to show up. And
Hmm.
then I'm thinking of trying to get one of these working with it.
Mm.
Hmm.
So then I can
Hmm.
control like a motor, forward, back, left,
Right.
right. I have let me show you.
yeah, I've done that before. That's a lot of fun.
Ah,
It's
Ah.
big Lego set.
wow.
Uh, so you can actually turn the wheels, right? So it's hooking up a servo to that. And then uh, it actually has a transmission here. You can throw it in neutral into different gears. And right now, when you spin the wheels, the pistons go up and down.
Mm.
So I was thinking of
It's
putting
always cool.
a motor in here, get the iPad to control it.
Yeah. Oh,
And I
nice.
think there would be enough room right there to put the Arduino in.
Okay. I was just going to ask you if you had any hardware on there yet, or if that was just the default vehicle at this point.
Yeah, right now it's just the vehicle,
Yeah.
but yeah, to motorize it.
Hmm. Hmm. Yeah, that's always fun. I'm doing that with one of my uh, numerous RC trucks right now. I'm building for a SRS contest that'll be coming in the fall, as far as either build challenges or Robo Magellan entry. I'm doing that with a larger RC truck as far as converting that into a robot platform. So that's a lot of fun. And I'm using for RC control, I'm just using one of those standard RC sticks, and then with the respective ESC and receiver that I'm doing for RC control on that.
So it doesn't go through Arduino at all. Though.
Well, anyway, so that's what it is. I was going to comment on next is that I'm what I'm doing is I'm hooking it up as a user control for either switch between autonomous control where the Arduino comes into play, or having it be RC controlled. In other words, with that transmitter and receiver
Right.
setup, and where the Arduino is just kind of the pass through for the for control. So I'm working on that implementation at this point.
Because the RC, how does that communicate wirelessly? Like, is it Bluetooth or is it
No, it's yeah,
the
that's a
radio frequency
yeah,
then?
yeah, radio control. Um,
27
let's see.
megahertz.
So that's another book reference that I wanted to comment on, talking about RC and Sumo, by the way, Sumo robots. Anyway, there's a great book by Pete Miles that does a lot of great talking in here about RC technologies in general. That's the reason why I'm mentioning this book. And he talks in there a lot of great detail about the communication framework for remote control. Realize too that RC, the equipment that I was showing before, that I'm currently setting up, there's a lot of history in the remote control um, uh, manufacturing and protocols and standards. And so they've got a whole, wireless technology that is employed for that communication that takes place between the transmitter and receiver. There's also some good online material as far as learning more about RC standards and the way to convert RC, or the way to in tandem use RC equipment and with like remote control, what it is I'm trying to do with this robot conversion for this truck, as far as allowing the switchability between RC control and autonomous control. And so there's some good. I can contribute. Graham, are you on the Discord server by chance?
I am, yeah.
Okay, so I can share some of those references that I speak of.
Yeah,
I
my
don't have that
name
kind
is
of information right in front of me.
the name I
So,
show up is completely different, but it's like
okay.
log
Anyway,
hoods or
I can
something.
put some of that stuff for you in the server, because I don't have the references right off the top, or I
Sure.
would put that stuff into the chat. But anyway, fun
Years
stuff.
years ago, we had an RC car that we wanted to put to make into a robot, and this was not the fancy RC where you have servos that plug into the receiver, and there's plugs everywhere. This was from Radio Shack, and they built everything on the same board. Everything was wired into it, and so there was nothing modular. So we had to figure out what to do. So I was able to diagram the circuit and find that there was a chip on the board that was like an 8-bit register. And so what I did is went in and actually cut the traces that came from the outputs of that register. And then the processor we wanted to use at the time was a basic stamp. So I put the basic stamp in a socket, and then soldered a ribbon cable to that socket, so that um, the ribbon cable carried 8 inputs and 8 outputs. And so then the ribbon cable, I cut just the right distances and soldered it so that it spanned the cuts and slashes, so that I was able to source the 8 bits from basic stamp outputs, and read the 8 register pins from 8 inputs on the basic stamp. So then the first program was just read all the inputs, write them to the outputs as fast as you can. And then you
Mhm.
try and use the RC controller and see if it worked as well as it did before we worked on it.
Mhm. Mhm.
And then we found that when we took the RC controller apart, there was a button that had been implemented in the circuit board, but had not been brought out on the case.
Mhm.
So we went ahead and drilled a hole and mounted our own button. And then when we traced it through to figure out what that did, it turned out that there were places that we could add like a diode, and that was all it needed to decode that extra signal that hadn't been used in this particular model. And so we used that as a way to get basically a shift key into the program that's running on the basic stamp. And so
Huh.
then you could use the controller normally, and then if you wanted to have it do something autonomously, you could push the shift key and like go up left, and that means go run this subroutine.
Mhm.
And so that worked out pretty well. We had it, making squares on the course or whatever you
Mhm,
wanted to have it do and then
mhm,
you could
mhm,
use the RC control to line up the robot carefully before you started one of the autonomous commands.
mhm, mhm, mhm. Yeah.
Yeah, that internal button maybe was a diagnostic mode they could get into. If
My guess is it's another model. Years and years ago, I had a television with a remote control, and at some point we took the remote control apart and found out it was also missing a button, and we wondered what that button did, and by pushing combinations of buttons on the controller, we found a mute function that particular TV did not come with, but you could by pushing two buttons it generated the same signal that the one button that was missing would have produced. And so you could actually mute the TV and not by pushing that pair of buttons.
Let's see, we are past the 2 hour mark, guys. So what else do we want to cover today? Anybody else have something to share?
I've been trying to build this finger starter because I'm a beginner, and I could share my screen what it looks like.
Okay, that'd be great.
This is what it looks
There we go.
like. Can you guys see it?
Yes.
Uh-huh. Yep.
Yeah. And I've built most of the parts, but I don't know how to make the finger like move, how to make the servo move. 'Cause I don't know the Arduino code, so I'm trying to learn the Arduino part.
Mm. So you've got the linkage between the servo and the finger itself?
Yeah, I just need one wire to just put the wire across, then I'm good.
Wow.
But
Oh, they give you real good detailed instructions, it looks like.
yeah, I just need the string part right here. And then this.
Is the finger spring loaded so that the string pulls against the spring?
Yeah, it pulls against this pulley, I think it's called.
Mm-hmm. But
Whenever it turns,
what
the
pulls it
finger
back?
just goes up.
Does the pulley go, does both sides of the pulley have a string that goes to the finger, or is it just one side and then the finger has a spring of some sort?
Both sides, because it
Oh,
goes from the bottom and then it goes out on the side. It's a string.
wow.
And then it's tied in the tip, so you could just pull it like a finger,
Mm-hmm.
where the servo just moves back. This is what I was trying to.
There's the Uno.
Yeah,
Oh,
yeah.
so they don't give you any code or oh yeah,
Think,
there's a finger starter sketch. There's a hyperlink there for finger starter sketch.
yeah,
Right there. Yeah. So that should
yeah,
give you a heads up as far as the way to start controlling it.
That
Yeah,
it.
yeah,
there we go. Here. Okay. I was hoping that they would give you a code starter with that project.
yeah.
Yeah. So you had talked about that you were working on learning Arduino. So what can we as maybe potentially help you get this project going further? What kind of questions do you have, especially in looking at the detailed instructions and then this code starter? What kind of questions do you have for us that we could potentially help with?
Think understanding the code. For example, if I wanted to write a code to move the finger, like would I be able to do it by myself? So for example, I want to build like the RC cars that you guys are building too. But for
Hmm.
that, I need to learn Arduino, right?
Right. Well,
So
they've. Oh
yeah,
yeah.
to
What were you?
move
Oh, please go ahead.
yeah, to move the finger, all they're doing is servo index right 90, right 0, right 180.
Mhm.
And so each degree is just going to be a different position for the finger.
Hmm. Hmm. Right.
So
And
who
they're
implements?
attaching it to pin 3. So
Which is
that's
where.
where you hook up the servo motor to
Right.
on the
That's
Arduino.
right. Right.
So who implements the servo index class? Is that in the Arduino stuff?
That's in servo.h, which is that servo library.
Right. Right. In fact, that's what that second line is from the top. That's a instantiation of the servo object that is contained in servo.h and servo.cpp or servo.c. Yeah, .c or .cpp. However, they have that defined for the library. So really, Mickey, you've got a full workable, if you've implemented physically for your physical finger, if you've gone through all those instructions that were outlined on that page that you showed us, and you hook and you install the Arduino IDE that we talked about previously in previous sessions of this group, and get all that going, and then just do a copy and paste of that code snippet that you also continue or showed us in the share screen, and then compile it and then download it onto your Arduino Uno that is ultimately hooked up to the servo that controls the finger. Well, then you should be good to go
I have
as
an
far
R.
as actually getting that implemented. Um,
Yeah, I have an R4 Wi-Fi, but I don't know how to connect the motor to the pin, like which pin it goes to.
Pin 3 and probably ground.
yeah, you
Ground.
gotta have to have the ground in there. So that's one thing too, Mickey, as far as doing those physical connections and understanding how to understanding that code that was included in that open source project
Yeah.
that you showed us, and also how to control the servo, how to hardware wise connect that servo onto the Uno board. All of that kind of stuff is in that Arduino cookbook, and real early on in the book, I might add. So that is a great resource for you to accompany this finger project that you're working on, because they actually talk about electronically how to hook up the ground connection, how to hook up that servo to pin 3 in your case, for the code to work. So in other words, you just need to do a little more digging as far as downloading that code, or creating a .ini file that utilizes that code. Once you have your IDE installed, if you don't already, and then doing some reference manual check, like with an ebook copy, free ebook copy of the Arduino cookbook, and you should be good to go,
Uh,
in my view.
Donna, it looks like one of the projects you sent us is for servo control.
Oh, right. Yep. That's very true.
Yeah.
Yep.
It's actually got 3 pins. So one's
Right.
your power, one's ground, and one's
And one
the
signal. Yeah.
data that
Right. Right.
that
Yeah.
changes the
That's right.
position.
Pin 3 is the signal pin. If that is being referenced there in the code base, Mickey. Okay. So yeah, Graham's right. There are three connector lines on any servo: power, ground, and then signal. And signal for your code is pin 3.
The motor end doesn't have like a pin on top of it. So how do you connect it with the Arduino? Do you need a pin in the
Well, you
middle?
need to have an interface cable. So
Yeah.
if you're looking at physically at your servo, there's the physical box itself, the servo horn, which is actually, in your case, connected directly with the mechanism that controls the finger itself. But the electrical connection for that 3-pin breakout is what it is that you need to connect in with the Arduino Uno. So you have to have a compatible interface cable. So they come in male female pairs, really for any of these cables that you will be working with Arduino for, including with servos. So I don't remember if the default one on the servo itself is a male or a female, but you have to have the opposite for the connector side. And that's that connector side. Usually they're called out in the color coding that's on both the servo, and then that connector cable is called out. It's delineated like by a black wire, a red wire, and then usually like an orange wire or some other third color. And then it's that third color that electrically on the back end of that connector cable, you've got your wire breakout, and where that signal wire then plugs into pin 3 on the Arduino board, and then the red wire or positive goes over to power, and then the ground goes over to the ground pin. So that's the way electrically that's hooked up. But again, those kind of details are in that Arduino cookbook
Yeah,
too.
I'm gonna
Okay.
read it.
Okay. If there's nothing else, guys, I'm going to have to be signing off here. Anything other hot and heavy that we want to discuss or share today?
That's it.
Yeah.
Okay. Great.
Thank you, Donna.
Yeah.
See you in 2 months.
Okay. Good. John, what were you going to say?
Oh, I said thank you.
Oh, you're welcome.
Yeah.
I know we covered a lot of theory that hopefully as you go in and you rewatch this recording and then you go in separately and you look at those links that I shared in the chat for a lot of the other reference documentation, that things will start to connect, and then looking at the C language itself, C++ language, and that everything will start to kind of flow together. Start making a little bit more sense for those of you who are not familiar with all that content. Okay. Okay.
All right.
Well,
Bye.
I'm going to go ahead and stop